Hi, today we're going to look at Microsoft SQL Server 2012's high availability feature called AlwaysON. Now, AlwaysON is something new within SQL Server and greatly improves the high availability capabilities of the database engine. How it is achieved is something that we're going to cover today, and this would be part of a three-part series where we discuss AlwaysON, how to set it up, what are the pitfalls with using AlwaysON, what are the benefits of using AlwaysON, and basically just an introduction sort of to how AlwaysON works and where under what scenarios you'd necessarily find using it to be an advantage. Now, as far as AlwaysON goes, there are a few things that you need to keep in mind initially. So let's just quickly cover what exactly previous technologies available for high availability were, and then from there we'll get into deep dive of what AlwaysON is. Now, traditionally in previous implementations of SQL Server, we really had just these couple of options available. The first one obviously being clustering, then we had database mirroring, replication, log shipping. Now these are one of the more common implementations that most organizations would have from a high availability standpoint, and each of these had obvious benefits as well as drawbacks, or not necessarily a drawback, but limitations as far as being able to satisfy all business scenarios are concerned. So unlike Oracle, where you have something called Real Application Cluster or RAC, we never really had a similar scalable environment or a scalable high availability solution that did both high availability as well as multiple secondaries that could be used for offloading business processes. With SQL 2012, Microsoft has aimed to mainly get rid of that limitation and try and make sure that with this new feature that's available, you can go ahead and do pretty much what you want to do as far as high availability or basically just database uptime is concerned, and at the same time being able to go ahead and make sure that you're not really wasting or underutilizing hardware resources. So as you can see in the diagram in front of me, what we're seeing is the traditional implementation where you've got one data center, which is your primary data center, and you'd have an active and passive failover cluster, and then you'd offload, move files or log files into the secondary data center or backups into the secondary data center, and you'd have failover clustering there as well in case this data center went down. Another implementation that you might have seen is something similar to this, where we have database mirroring, where we have both the primary as well as the secondary, and then we've got a witness who takes care of the automatic failover during high safety mode. In addition to this, we would normally have database mirroring combined with log shipping to go ahead and offload the data into secondary data centers. However, with all this, you see that the primary limitation that we have is while we do achieve maybe failover at the instance level or failover at the database level, we never really got the ability to go ahead and do much reporting out of the secondaries that we have. So a lot of hardware was underutilized. With the new AlwaysON capability, what you can achieve is something similar to what you're seeing on this diagram, where you have the primary, which is again this replica here, and all users connect to this particular replica when they want to do a read or write operation. But at the same time, the primary replica as well as the replica 2, 3, and 4 are all part of the same failover cluster. And as you can see here, the primary replica instantaneously goes ahead or synchronizes its data with two other replicas, and at the same time asynchronously replicates with replica 4 as well. And while this is happening, you can see that you can offload backup operations as well as reporting applications from any of the secondaries. So technically what you have here is you've got 4 copies of the same data, albeit this one could probably be slightly out of date, and really you need to be aware of the limitations of asynchronous data transfer and how it impacts reporting and backups. But the idea here is that you technically have multiple copies of your database all up and running, and you can use any one of them to go ahead and do offload business processes. That could be backups, it could be database integrity checks, it could be reports, except for writing into the databases. Everything else you can pretty much do from these other databases. So in order to do this, there are some basic assumptions that Microsoft makes as far as the user requirement for AlwaysON is concerned. The first one is that all of these replicas that you see here should be part of failover clustering. Now, one of the good things is that, as you can see here, each of these are standalone instances, so now there is no longer a requirement for shared storage, unlike in clustering. In addition to this, you will see that there are some other couple of benefits available, but before we can really get into that, we need to understand what AlwaysON is about. AlwaysON, basically, if you think about it, is really just a combination of 3 different high availability features. This you could think of in terms of being clustering, mirroring, and replication. Now, each of these different high availability solutions have their obvious advantages and disadvantages. I've listed a couple of them here. For example, clustering has instance level failover but no database level failover. Also, there is a requirement for shared storage, and the secondary or the passive server doesn't really contain the databases, so while the hardware is still up and running, technically it's not usable, unless of course you're using an active configuration. Similarly, in database mirroring, you have database level failover, but unfortunately you don't have instance level failover. Also, database mirroring has a 1-to-1 mapping, so you just have one primary and one secondary. And the secondary is not available for any offloaded reporting or backup purposes, so technically, again, the secondary is an unavailable hardware resource. Now, if you come into replication, you'll see that in replication, obviously, we have multiple secondaries and we can offload backup and restore operations and reporting and stuff, but there is no automatic failover, neither at the instance level or the database level. So technically, each of these different availability solutions have a good role, but they don't really fit well with satisfying every aspect of an enterprise system. This is where AlwaysON comes into picture. With AlwaysON, you have a combination of the best of all these 3 different high availability solutions without any of their weaknesses. In the next video, we'll go ahead and explore how to go ahead and configure or set up AlwaysON. With this, you should be able to go ahead and configure AlwaysON, and while doing it, get an idea about how powerful AlwaysON is and what you can do with it. Again, the caveat here is that AlwaysON does not meet all business scenarios, and there are certain limitations that you need to be aware of. We will discuss this in the upcoming videos. Thank you for watching. I hope you've enjoyed this video. We'll continue this discussion in the next video, where we will configure and set up AlwaysON.